P6-7 is a good project to compare the bottom-up, multi-body, and top-down strategies. This video is going to cover the multi-body strategy. With multi-body, maybe we don't need an assembly. We just need to have a purchase part that we're going to build into an assembly and don't need to have separate files. But the advantage is that we can always output these to separate parts and create an assembly if needed. So something like the hex bolts, we would add that to the assembly, but there are some limitations to the multi-body. So if there's more than about 3 or 4, maybe 5 parts, let's go ahead and open up the metric part. We're going to probably be better off with top-down. There is limitation with the multi-body that there at a certain point the complexity it just doesn't help to build in more bodies. All right, so I'm going to draw the circles. So the threaded hole, the bore, the bolt circle, and the outside. So we should be able to go 100 and 75 and 60. And then we want the minor diameter for the thread. So 24 minus 3 is going to be 21. The outer segment, let's see, we had, just going to check the number. So this will become the bolt circle. And I would like to go ahead and build in the pattern for the bolt. So just dropping a point, and then do a circular sketch pattern, and we can pick the point to pattern, and we want a total of 8. So we'll put those in. All right, so the thing to be aware of is often the sketch pattern. Oh, I jumped before I could do it. Let's see if I can undo. Nope, it's going to drag that out. I think it snapped the point at the center. So, well, let's try that again. Let's see if my redo works. All right. Okay, so I can drag it out. There we go. The center point, if you're in the hole wizard, you do want to watch out for that center point because it's going to add a 9th instance. Advantage of a regular sketch is that I can drag it to the origin and place it, and it's going to go fully defined, or I can drag any of the points back to my bolt circle and not worry about dimensioning the angles or dimensioning the radius out of that command. Okay, so out of our geometry, this is going to be my layout sketch that we're going to start making features. I would like to drive everything from this sketch, but I don't want it to be in the part, so to speak. So let's go with converting the entities, and we'll build those up with our geometry. So I could also make another sketch that has all the heights, but let's go ahead and extrude these out. So since there's multiple regions, we'll go 65 on the height, and then expand that out and share the sketch. So this is going to be our cosmetic thread side, or the side that we would add the thread wizard to. So let's go ahead and extrude that out. Sketch 2 automatically gets selected. I don't really like leaving those in there, so delete that out and go to 20 on the height. For the hole locations, then let's go to the hole wizard, and we're going to pick metric bottoming tapped. We're at an M8 point by 0.1 or 1 point, so that's a fine thread. and go a little more coarse. We'll go blind 17 millimeters deep on the thread. So then we should go a little deeper and on the tapped holes so that there's more than enough geometry. All right, so if we get the 2D sketch, 3D sketch, we need to make a selection. Otherwise, we're in the point command, and we're just going to go along and add those points, making sure that they go coincident to our bolt circle. All right, so on this geometry, I would like to go ahead and add that to a new folder. So this is going to become the pressure cylinder base. This would also probably be a good time to go ahead and save this. So let's find our way to our project folders, and we're going to do a new folder, assignment 8, P6-7, and this is going to be the pressure cylinder. And because it's a multi-body, I'm going to put a -M or some designation that lets me be able to tell them apart. Because if I name the assembly and the drawing pressure cylinder, there's going to be associativity back to this part. So if I open up a sketch on this part, and the risk is that if I delete or have to change this part drastically, it's going to affect the downstream parts. So when we do top down, I like to have a single point of failure with multi-body, and maybe can mix it up a little bit more, but you're going to run into those types of issues with our geometry. So since I'm here, I'm going to go ahead and name this base and then hide it. So I opened up a sketch on the top of the base, and that's where I'll be drawing from. And when I go to my gasket, we will convert those entities, and it puts it on top of the at the base, and then we can draw the circles. We've done Control C, Control V before. I could also pattern these, but if I do a Control C and a Control V, and those are getting close, even though I'm picking, they're not going fully defined. So just be aware that on your geometry, you are going to have to go back and add those relations. So we're going to set all of these equal. And then for an 8 millimeter clearance on the gasket, I might even want to have a little bit of interference to the thread. And that does not look like it applied equal. I don't have anything in the existing relation. I don't think it grabbed it. So no, that one. All right, well the test will be to add a dimension, and we'll go like 8.2, and they did all change. So even though I was expecting to see that existing dimension, it did get it. So we're just going to go back and add these. So advantage is going to be to the sketch pattern, but if you want to tie it to these points or drive with these points, there are some options available. Okay, so that's going to extrude 3 millimeters, and we'll go ahead and accept it, and then that becomes the gasket. Okay, and once again, we'll open up a sketch on the top of the gasket and then immediately hide it. And the cover then, let's go ahead and do the whole wizard on this one. So we can go with the convert And then we'll pick up. Now let's just go ahead and do hole wizard on both of them. So that one becomes an extrude and 13 millimeters. And we go ahead and pick the face, open up the hole wizard, and we're going to do a clearance. So anti-metric screw clearances to an 8 millimeter. It's going to go to 9 millimeters, which is a little on the high side if we look at the custom sizing. And we want to be up to next, but there'll be plenty of room. So in this case, if I go back to the points, I would be interested to see, since we're in the hole wizard, if I do the circular pattern, and we'll just do the 4, and notice that there was no center point. So you do have to watch previous versions. The hole wizard did not remove that center point, and you ended up with an instance count that was +1. So again, I could do the circular pattern, or we can pick the points. And what happens is if this number changes, the gasket, the threads, the through holes, those all change with it. All right, so for this hole wizard, we're going to go to the M24. Oh, we need to be in threads. So let's go ahead and pick and make sure that we're in metric. And we'll find our M24x3 up to next. One of the things we would want to watch for is the feature scope, because we're dealing with the solid bodies. The advantage of hiding those is that it doesn't recognize the other two parts. So when it selects, it's only selecting the shape. If the other two were visible, then it might pick the base as well. So we go and make the selection, and that's going to automatically add the cosmetic thread. So this one's going to be the cover, and we'll go ahead and make that capital. All right, so when I show these, you can just right click and show. We have all three of our parts. I can hide the layout, and then on the base, since I drew that one in, we would want to go, if we've added the cosmetic thread, to our command manager, or we can start typing it in to the search. And then the long way is to go to insert, to the annotations, and then to the cosmetic thread. So whichever one of those works. We're going to find the geometry. It jumped M24x3, and it's going up to next. And I usually turn the show type off, because in the drawing I want it to be a dimension, not a note. All right, so we're going to do Control-1 so I can see it from the front. And we'll make sure to save it. And then at this point, we can go ahead and export these. If this is all I needed, maybe I would even draw the hex heads in for representation. But we can do things like on the base, we'll set the material to 1020, and we know the cover is also 1020 or steel. And then the gasket was neoprene, so we'll have to go into our material and edit. And we're looking for rubber, neoprene, and if I didn't know what category it was in, I could just type it into the search and have it find it. So there's our pressure cylinder. And then we have the option of inserting into a new part, which would do an individual component, but the save bodies will grab everything, output them to their parts if we need it, and also then we can make an assembly. So if I browse, then we'll go to pressure cylinder. And we'll go ahead and accept that. And my default parts were apparently in, so it's asking me to update the units. and then it's going to add the save bodies. So the save bodies, we do want to be careful. We don't want to suppress in these because it renames to the last feature. If I need to add features or make adjustments, I want to do the rollback bar rather than changing the suppression state. So I can add bottom to a new folder. That will be the cover. And then anything that I do after this, I got a minus sign, so where did the minus sign come from? So one of the clearance holes did not, yep, one of the clearance holes did not line up. So those minus signs are pretty important. So when you notice it, that's the time to correct it. All right, so anything that happens after the save bodies does not migrate back to the assembly. So like we go to the assembly, there's our part, and we do the rebuild. So if I were to go into my components and do something like the direct editing to move copy bodies, and it's not set to copy, and we'll go like 75 millimeters and accept it, then that takes place after the save bodies, where if it took place before, it would migrate downhill. So the suppression states after the save bodies, or we create a configuration, we could manage those outside of the part. Okay, so in the pressure cylinder, we want to find our, oh, it's up. So the McMaster, and let's just go back to the start and run through the process. So the fasteners, hex head screws, looking for metric. Length, not so much, but thread size, I want M8s. I don't need super high strength, even though it's a pressure cylinder. I would think that an 18.8. One of the advantages of the 18.8 stainless steel is that it has good corrosion resistance, reasonable strength, and if I do manage to break one, it is going to be easier to repair the part, drill it out, whatever we need. All right, so if I go to, did it jump? No. Okay, there's my part, M8 by 1.25. And if I tell it to download the 3D Solidworks, then it's going to put that into the downloads, and I'm just going to go over and cut it and place it into the same folder so that I have access to it. Now you could use the toolbox, but this is more of an example if you don't have the toolbox in your license, or you need a special custom thread. We can generate that geometry. So one of the things I don't have is a mate relation, and this is probably an older version. So if I go ahead and open it, I would like to pick, oh, that actually had a little bit of shoulder on it. I didn't catch that. All right, well, if I needed fully thread, I would go back and grab it again. Let's go to the mate reference and OK, and make sure it saves. And partially threaded. So we do have to pay attention, partially threaded and fully threaded. So if it was, I think it made a difference. We'll see what it does. All right, so over into the assembly, we're going to go back to the insert. Now it's going to snap, and I'm going to be able to drag and drop, just holding down the control button and dropping those in place. All right, so because of the partially threaded, I do want to look at this in the front view, the hidden, and the partially threaded is not going to cause any problems there. So once we have that, we're going to be able to create our exploded view. And the exploded view here is not going to be the same as doing the move copy out of the part. Oh, and one thing for the mates, if you really want, those minus signs bug me. So if I go find the concentrics and right click, I can lock the rotation, and that'll just leave them in the position that they are. We'll go ahead and make sure that it saves. All right, so into the exploded view. We'll go ahead and grab bolts. Now it did pick a face, and I did not want it to go X. I do want it to go Z though, so let's clear the selections. Okay, it gave me the direction, but it still didn't like that one. So let's go back in and make sure that it gets selected. All right, so they all go out. We're an inch in the assembly, so 5 inches would be fine. And then we're going to go done. And then the next group, we can do the gasket and let it auto space. All right, so if you wanted to do all of those at the same time, you can, but sometimes it's easier to manage the geometries. All right, so we'll go ahead and save that and go into our, let's just do a make drawing from assembly, and we'll pick up the ISO a landscape template. You can use the ANSI a landscape. We'll bring in the isometric exploded. That looks a little bit on the small side, so let's go to half scale. And I want to go into the tables and pull up the bill of materials. So it has the standard, and it goes to all of the bill of materials. And one of these times I got to take the bill of materials that I made and put under my system. Nope. Oh, that might have been it. Okay, part number, bill of materials, and then place it. All right, we'll rebuild. Now, would have expected that the bill of materials, we didn't apply any part numbers, but it doesn't look like the material was carried over from the assembly. Or I haven't opened the parts just yet. All right, well, let's go with, we've been doing auto balloon. You can always add balloons individually. Before the auto balloon became more reliable, I would just recommend that you do the manual balloon, because it was about as fast as making the corrections. All right, so let's go ahead and pull in, let's refresh, and we'll bring in an isometric view and go that way. So that little line told me that this is in alignment. It's not going to move up and down, which doesn't necessarily hurt anything, but we do want to watch for that. Go into the alignment and break alignment if you want to be able to move it and position it where you need it. Okay, so I'll save for the drawing. We'll add the next view. And then one of the things that comes up with the downstream parts, I'm not seeing, so we need to do the ... And once we've picked the ellipse, we'll go to the base. Then that will update. We'll go to the top and the isometric, because I want to go into the section view. So our drawing, the section view, and we'll put that in place. All right, so under the annotations, I've had issues before, so I want to check. Notice that the associated part, the saved body, has a depth of minus 1 meter, 1,000 millimeters. So that's not a good way to go. So if we go back to the original, and if I did not create the assembly and the separate parts, I would just be bringing in the multi-body part. We can do the same thing. We'll bring in the top. Go ahead and set the isometric. But then on this view, I want to select the view, go to select bodies, and then I'm just going to pick the lower. All right, so that brings that in. And when I add the whole call out, now it has the 22 millimeters. So it's just something to watch out for. Some of the strange things that that happen in that associativity. So once more, select bodies. We'll select the view, select the bodies, go in and select the component. And the cosmetic thread came with it, so let's see if we can... Now it's not letting me select it. There it is. Well, I thought I had it. And let's see if we can hide just the cosmetic thread. All right, so a little bit of cleanup there. All right, so let's go into the section view again. We did not bring in our center lines. I do want to demonstrate one way of bringing the angle, and it depends on if I can find the center here. It looks like it's going to override to the section view though. So to that point, and then it's not picking that. So maybe I'll undo just for this illustration. And we'll go to the smart dimension. And it doesn't seem to be picking up my center points. Finds that one, finds that one. Well, because I really want it there, we're going to go point, point, and should be able to get one more. No, it looks like it's gonna fight on that one. So, all right. Well, what I'm looking for is if I can get those 3 points to select, I can get it to go to an angle. Worst case is I'll just draw in the center line. So while I'm here, I'm going to go ahead with the center marks, and we're going to go for all holes and accept it. Now, I did not put it on the layer that I wanted, so I can go into my filter, and we'll pick all of those. And I think it's a better habit to do it out of the property manager. I'm pretty sure I could pick it over here on the list, but now that I've finished the filter, I need to go turn it off or hit F6 to toggle it off. And then in the drawing, we can go back to the section view, and we'll hit OK. So now that I've done that a couple of times, let's switch it to A, and no A is not being used. And one of these times I have to fix the font too, but that gives us enough of our geometry that now I can go in and start adding the dimensions. So 100, 60. I would like to have a center circle, but there isn't really a center circle. So we draw the circle, we switch it to for construction, we put it on the center, and go ahead and accept. And then that gives us something to dimension to. And yes, it's going to be driven. And I would also like to put the note that that is a bolt circle or a base circle. Okay, maybe not that way. Here we go. All right, so we have the 8 times, we have the bolt circle equally spaced, and our depth and the through. So that leaves then on the annotations, if we go to the whole call out, we should be able to find. So that one went to the 21 by 20. So let's go over to the smart dimension, and even though it didn't call it out quite the same, we're going to see the difference and the advantage of the whole wizard. All right, so let's go ahead and bring in the cover. Shouldn't have the same issue, so we'll go to the ellipse, grab the cover. I'm not going to do the gasket because it should be a purchase part. If we have to make one, then we'll detail it. So side view, same thing with the cosmetic thread. Make sure that can highlight and hide. All right, so on our dimensions then, pull those. This time when I do the whole call out, I get the 21 through on the M24 by 3. So that's the primary difference between drawing it in and using the whole wizard. And if I do the whole call out, this should be the 9mm through. If we go with, let's see if this one will do the example of the centers. Yeah, it's still wanting to do just the linear distance. When it works pretty good. When it wants to put up a fight, not so much. All right, so center point to center point. And let's see if I can go smart dimension to the angle, and we can use the center line to generate our angle just the same. Make sure I can get the thickness in there. All right, so there's a lot of little tricks and traps in the detailing and the model, the multi-body models. So we do want to watch out for notations. We want to check the instance counts. So in this case, it didn't do the instance count for me. So if I modify the instance count, yes, I typically put the times 8 times in a large X. That kind of is a signal that I manually modified that. Where if we come back over to, what is it, this one? Well, let's see, 9. No, that one didn't do an instance count either. So if it does an instance count, it does it at a small x. So, and it's warning me about altering. Okay, so one more save, and we'll call that that good.